Alrighty, everyone. We are about to do the last part of lesson 9-1. Okay, and we are starting on page 139 here. And so now we're going to be talking about a method that's called completing the square. And this is a method that you can use when you have all three terms. You have the ax squared, the bx plus c equals 0. Okay, so it's got to be in standard form. This is a method you can use when it's in standard form. You have the ax, the squared, the bx, and the c. Okay, completing the square. Okay, completing the square is the process of adding a constant to make it be a perfect square. And by that I'm talking about, I'm going to go back to the warm-up for a moment. Okay? In the warm-up, we got perfect squares. So remember on number 1, okay, we got x squared plus 5. And so when it says adding a constant, it's talking about the number at the end. This is the constant, the 25. So let's pretend for a moment that the 25 wasn't there. What number could we add to it? Let's pretend like we don't know what that number is. We know this. Oh, actually, we don't even know the answer yet. Okay, we don't even know the answer yet. All we know is x squared plus 10x plus question mark. What would go in this question mark to give us a perfect square? Remember, I pointed out the fact that the middle term is 2 times. So you notice how in this example we have 7 being multiplied by 2 here and then squared here. Well, the way this would work is we would work backwards. So we're always working backwards, right? So this is 2 times something. Okay? 2 times what? Well, 10 divided by 2 is 5. And then the number that would complete the square would go here would be 5 squared, which is 25. That's the number that would go here. And that works for the next one too. If I took the 14 and divided it by 2, we'd get 7, and then if I squared the 7, that would give me 49. And this factors into x plus 7 squared. So the 7 is in the middle being doubled and at the end being squared. This is the pattern that we're using. So keep that in mind as I work through the examples for today. So it's the process of adding a constant to a quadratic expression to transform it into a perfect square. So our example could be here, x squared plus 16x. What constant could I add to this to make it a perfect square? Well, using that pattern, so 2 times what gave us 16? Well, that would be 8. And if we want this to be a perfect square, then we would take the 8 and square it to get 64. So that would factor into being x plus 8 squared. You double the 8 and square the 8 to get 64. Okay, so that's the pattern. You might want to add this to your chem chart just to help you study. But let's take a look at this example here in the book. So solve 2x squared plus 12x plus 5 equals 0 by completing the square. So notice though that there is a 2 in the front, and of course they throw a problem like this first. So you notice you do have a leading coefficient of 2, and it's kind of like a GCF, except we're not just factoring it, we're solving. So whenever we can actually divide both sides by 2 and essentially cancel it out. And that's what they do here. We want our leading coefficient to be 1. Okay, that's the goal. What's 2 divided by 2? Is 1. So we divide by 2 in the front here, and when we do, we have to divide everything by 2. So that cancels out to give us x squared. 12 divided by 2 gave us 6, and 5 over 2 is just 5 over 2. Okay, and then that leaves us here. Now it says to isolate the variable terms on the left side. So we want the important parts, the x squared and the 6x on one side, which means we need to get rid of the 5 halves. So I can just do that by saying minus 5 halves on both sides. Now, where the 5 halves used to be, I like to, you want to leave a blank. Leave a blank right here, and they actually write it right here. Leave a blank. Okay, what's going to go in the blank, you ask? Well, that's where this part comes in, okay? The blank is where the number that's going to complete our square, that's going to make this a perfect square. So to do that, to find the number that's going to make this a perfect square, we take our 6. 2 times what gave us 6? Well, that's just 3. And then to get what goes in the blank, we take the 3 and we square it. And actually, I'm going to make that 3 a different color. 2 times 3 gives us 6, and then 3 squared will give us 9. But notice how we're adding a new number to our problem. We're adding 9 to the problem. And what we add to one side, we have to add to the other. Got to keep it balanced, right? And so now notice we've got to combine negative 5 halves and 9. So we need common denominators. So I need to get 2 on the bottom, so times 2 times 2. So I have negative 5 halves plus 18 halves, which gives us 13 halves, which is where they got that from. Now, where did they get x plus 3 squared from? They have to factor this. Factor this guy. So our number was 3, right? Here's how to think about this. Take the 6, divide by 2. That's 3, right? And then double check. 3 squared gives us the 9. Why do I want to factor this here? Well, it's because we've learned about solving these equations by taking the square root. So now we have a square root problem. We have a problem that we can just take the square root. So it says factor the perfect square trinomial. Okay. Now take the square root of both sides. So now I can just go square root of x plus 3 squared equals plus or minus the square root of 13 over 2. When I do that, that cancels out the square and just leaves us with the x plus 3. And now we can just solve this. We need to simplify this. We have the square root of 13 over the square root of 2, which they have here. And notice how they rationalize the denominator. By doing square root of 2 on top and bottom. 13 times 2 is 26. And then we just end up with 2 on the bottom. So we end up with x plus 3 equals plus or minus the square root of 26 over 2. And now we just need to subtract the 3 from both sides. And we get x equals negative 3 plus or minus the square root of 26 over 2. So really the crux of this lesson is understanding what happens right here. Okay? What happens right in here? Like understanding where did the 9 come from? How did we change from this to this? So I'm going to pause right here and I want you to answer this question for me. What number completes the square. So if I gave you x squared plus 15x, what number would I put in the blank here to make this a perfect square? Okay, I'm going to stop and let you answer that.